Hey there! Welcome to the bustling Linux apartment complex, where every file and directory is a unique space. Are you ready to jingle the keys to these rooms? Let's dive into the world of Linux permissions together. In this adventure, we'll meet the various residents, understand how permissions act as keys, and learn how to control access to keep our community secure and functional. Let's unlock the secrets together. First, let's check who we are in our Linux apartment. The whoami command is like glancing in a mirror inside your apartment. It reminds you of your current user identity, which is important to know as it determines what rooms you can access and what keys you hold. Next, let's meet everyone else. Walking down the Linux apartment's hallway, we see different doors with names. Each line in the passwd file lists a user, with their username in the first column and other information in the following columns. Users in Linux are like apartment residents, each with their roles and responsibilities. Now let's learn about groups in Linux. The first column of the group file lists the names of the groups present on the system. Groups are like apartment social clubs or roommate arrangements, defining shared access and privileges. They're crucial for organizing who gets access to what, from the laundry room to the storage closet. Finally, let's see which clubs we belong to. Using the ID command, we can get a quick overview of who we are and the clubs we're part of. It's like getting a full profile of our access. We can also use the ID command to get other users' information to see who has the keys to shared spaces. Are you ready for a little mission? Find another inhabitant of our Linux apartment, learn about their club memberships, and see how they stack up to yours. Ready, set, pause, and investigate. First, let's list the users and pick a user. There's dozens of users listed. Most of these users are system users, not human users. System users could be thought of as essential staff in an apartment. Let's pick the ever-powerful root user and see the groups that user is a part of. The root user is a member of the root group alone. The root user is like a building superintendent who has access to everything in the building. We'll talk more about this ever-powerful user later in this tutorial. With the ID command, we've uncovered not just who we are, but also our memberships. You can see that we are not a part of the root group, which the root user is a part of. Notice that the ID command prints information about the current user when no argument is passed to it. Did you learn something from this challenge? Hit subscribe and join us for more Linux escapades. Let's start by looking at the permissions of files in our Linux apartment. The first column in the output of ls-l shows the type and the permissions of that entry. Let's take a closer look at it using the file permissions.txt. The first character, a D or hyphen, indicates if it's a directory or file. The next 9 characters represent permissions, divided into 3 sets of R, W, and X, representing permissions for 3 different categories of users: the owner, the group, and the others. Now, let's see how to find out the user and the group for a file, and how the 3 sets of permissions control access. When a file or directory is created, it gets assigned a user or owner and a group. You can see the user and the group of permissions.txt in the 3rd and 4th columns of the output of ls-l. In this case, the user and the group are both Kavi. We'll talk about how these assigned owner and group can be changed in a separate tutorial. The 3 sets of permissions assigned to a file or directory are the owner, the group, and the others. The owner set refers to the file or directory's creator or assigned owner. The group set refers to the all members of the file or directory's group. Lastly, the others set controls the default level of access for all other users in the system. Now let's break down the types of permissions: R for read, W for write, and X for execute. Read allows viewing the contents, write allows modifying it, and execute allows running it as a program for files or accessing it for directories. Now that we understand these letters in the output of ls-l, let's see what permissions different users have on permissions.txt. The owner has permissions to read, modify, and execute the file. The users in the group and all the other system users can only read the file. Alright, time for a quick challenge. Let's find out the permissions of the /etc/hostname file and see if we can edit it. Go ahead and pause the video, give it a try, and come back to see if you got it right. First up, let's peek at the permissions of /etc/hostname with LSL. Root owns it, with the root group also having control. We, mere mortals, only have the power to read. Quickly, let's confirm our user identity and group memberships with the ID command. Knowing who we are helps understand what we can do. As we thought, we're not root nor part of the root group, so we should only be able to read the hostname file. We can use cat to confirm we can read the file. Let's see what the hostname of this system is. And yes, we can read the system's hostname is machine. Now, let's get a bit adventurous and attempt to rename the system to Enigma. Just as we thought. We don't have the required permissions to change the hostname. If you're enjoying unraveling the mysteries of Linux permissions, hit that subscribe button for more tutorials. Before we proceed further, let's touch upon a special resident of our Linux apartment, the root user. In Linux, the root user or super user has unrestricted access to the entire system, much like a building superintendent with a master key. The permissions we've talked about in the previous section do not limit the root user. They can enter and modify any file or directory, regardless of the set permissions. With great power comes great responsibility. Misuse can lead to system damage, which is why its use is usually reserved for essential system administration. Stay tuned for a dedicated tutorial on the root user. We'll dive into best practices to ensure you're well equipped to manage your Linux apartment responsibly. Now that we understand permissions, let's learn how to change them. First, let's check the current permissions of a script named hello.sh. Notice the owner has permission to read and write, but not execute the script. Let's give the owner the permissions to execute it. We've used chmod to add execute permission for the owner. The U here represents user or owner of the file, and the +x instructs the command to add the execute permissions. Let's see how the script's permissions have changed. Yay! The owner now has execute permissions on the script. As another example, let's remove the ability of anyone other than the owner to read the file. Now only the owner can read, write, and execute this script. We remove the permissions for the group and others using the G and O letters respectively, and the -r suffix to remove the read permissions. Let's quickly verify using the ls command. There we have it. Changing permissions using plus and minus instructions is intuitive and easy to understand, but may not be precise enough for some use cases, since the final permissions depends on the previous permissions state, which may be unknown. For more precise control over permissions, we can specify explicitly what each category of user can do. This command explicitly gives read and execute permissions to all users and write permissions only to the owner. But this is verbose and too long to type. Let's introduce a more compact way to set permissions using octal numbers. Each permission type has a value. Read is 4, write is 2, and execute is 1. These values can be added up for each permission set. For example, R, W, X would add up to 7, R, W would be 6, and R, X would be 5. And we combine these numbers to form a 3-digit number, representing the permissions for the owner, group, and others. 755 would be the equivalent of giving permission to read and execute to all the users, and write permissions only to the owner. 644 would be permissions to read and write to the owner, and permissions to read to all the other users. Let's set the permissions of hello.sh to 755. We use chmod with the octal mode to set the permissions of hello.sh. This is equivalent to the command we've run above. You can see that the permissions on the file are as expected, only we have permissions to write the file, and everyone else, including ourselves, can read and execute the file. Challenge time. Let's say you've written a diary entry in journal.md and you want to make sure only you can modify it, but your friends in the same group and others can still read it. Try setting the permissions to allow this. Pause the video, experiment with chmod to set the right permissions, and resume playing when you're ready. First, let's create the journal.md file with our entry in it. We've created the journal file with some text in it. We created the journal file in /temp, because on most operating systems, our home directory wouldn't be accessible to other users. As you can see, users not in our group don't have permissions to read and execute on our home directory. They will not be able to list files in our home directory. Let's check the permissions on the journal file. Users in our group other than ourselves also have write access to the file. Let's change the permissions on the file. Only we can edit the file now, and everyone else should be able to read it. How did your attempt at the challenge go? Were you able to correctly set permissions on the journal file? Understanding chmod is essential to maintaining security and control in your Linux apartment. If you enjoyed this tutorial on Linux permissions, consider subscribing for more.